The McDonnell F-101 Voodoo is a supersonic jet fighter which served in the United States Air Force and the Royal Canadian Air Force. The origins of the F-101 actually had little to do with the jobs for which it was used over its long career with the US Air Force, Air National Guard, and Canadian Armed Forces. Neither tactical reconnaissance nor all-weather interception had been a factor in early 1946 when the newly formed Strategic Air Command solicited proposals for a jet-propelled strategic penetration fighter. SAC's chief criteria at the time had been sufficient range to accompany its bombers, Boeing B-29s and the soon-to-fly Convair B-36s all the way to their targets, and adequate speed and firepower to deal with enemy interceptors. 4 swept-wing designs were ultimately approved for prototype development: the McDonnell XF-88 Voodoo, Lockheed XF-90, Republic XF-91 Thunderceptor, and North American YF-93A, a development of the F-86, all of which flew between 1948 and 1950. After being awarded a contract on February 14, 1947, McDonnell built 2 prototypes, designated the XF-88 Voodoo. The first prototype, serial number 46-6525, powered by 2 Westinghouse XJ34-WE-13 turbojets, flew from Morocco on 20th of October 1948. Preliminary testing revealed that while handling and range were adequate, the top speed was a disappointing 641 miles an hour at sea level. After fitting McDonnell Design's afterburners to the second prototype, thrust was increased to 3,600 pounds with corresponding performance increases in top speed, initial rate of climb, and reduced takeoff distance. Fuel consumption was greatly increased by the use of afterburners, however, reducing a range. When a fly-off was held in the summer of 1950, McDonnell's XF-88A, an improvement over its 1948 prototype, emerged as the winner of the penetration fighter competition against the Lockheed XF-90 and North American YF-93. McDonnell's success was momentary. However, the Air Force, motivated by unexpected budget cuts, abruptly canceled the XF-88A program and made the decision to use the Republic F-84E Thunderjets as interim bomber escorts. Combat experience in Korea soon revealed that the straight-wing F-84s were not suited for air-to-air role, and the North American F-86 Saberjet clearly lacked the range to escort bombers to long-range targets. Something better was needed, so SAC, determined to protect its emerging fleet of B-36s, issued new requirements for a long-range fighter in January 1951. This time, adding specifications for parallel development of photo reconnaissance versions of the new type. Lockheed, North American, Republic, and McDonnell all submitted new proposals, joined by a bid from Northrop for a long-range version of its F-89 Scorpion. In May 1951, the Air Force announced that McDonnell's entry, basically a scaled-up XF-88A upgraded with more powerful Allison J-35A-23 engines, was the winning bidder. But before construction was authorized, the Air Force specified major changes aimed at improving overall range and performance, the most significant being the substitution of Pratt & Whitney J-57P-13 power plants, which required enlarging and lengthening the fuselage to carry more fuel and house bigger engines, plus extensively revising the air intakes and related engine ducting. The greater dimensions of the J-57 engines required modifications to the engine bays, and modification to their intakes to allow larger amounts of airflow into the engine. The new intakes were also designed to be more efficient at higher Mach numbers. In order to increase aerodynamic efficiency, reduce structural weight, and alleviate pitch-up phenomena recently identified in flight testing of the Douglas D-55-82 Skyrocket, an aircraft with control surface configuration similar to the XF-88, the horizontal tail was relocated to the top of the vertical stabilizer, giving the F-101 its signature T-tail. When the McDonnell team, led by Edward M. Flesch, completed the final design in late 1951, the Voodoo had grown 13 feet longer and weighed twice as much as its XF-88 predecessor. The F-88 was redesignated the F-101 Voodoo in November of 1951. The F-101A would be, at the time, the largest single-seat fighter ever built, 67 feet 5 inches long and weighing over 48,000 pounds fully loaded. Although the wing had been slightly enlarged by increasing the chord of the inboard half of each panel, total area was still relatively small, 368 square feet, producing prodigious loading of 135.9 pounds per square foot, the highest of the Century series in original configuration. Internal fuel capacity increased from 734 to 2,341 gallons, augmented by two 450-gallon external drop tanks. Provisions were also made for an in-flight refueling, either via flying boom or probe and drogue systems to extend the plane's combat radius even further. An APS-54 search radar provided all-weather capability, and heavy firepower came from four 20mm cannons, 3 Hughes AIR-1 Falcon radar homing missiles, and up to 12 unguided rockets. Before the final design was fixed, the Air Force expanded the fighter's potential mission uses by adding the capability to carry a nuclear weapon on an external rack. In late 1952, the mission of the F-101 was changed from penetration fighter to strategic fighter, which entailed equal emphasis on both the bomber escort mission and on nuclear weapons delivery. The new Voodoo mock-up with the reconfigured inlets, tail surfaces, landing gear, and dummy nuclear weapon was inspected by Air Force officials in March 1953. The design was approved. An initial order for 29 F-101As was placed on May 28, 1953. No prototypes had been required, as the F-101 was considered a simple development of the XF-88, with the Cook-Craig production policy, in which initial low-rate production would be used for testing without the use of separate prototypes, chosen instead. Not surprisingly, a decision was made to limit production to the initial procurement until military acceptance testing and evaluation was well underway. The first F-101A was completed in August 1954 and shipped to Edwards Air Force Base, where its maiden flight was on September 24th, with McDonnell test pilot Robert C. Little at the controls. Early testing indicated impressive performance, a top speed of Mach 1.54, an initial climb rate of 44,100 feet per minute, a service ceiling of 49,450 feet, and a maximum range of 2,186 miles. It also revealed aerodynamic flaws that were serious enough, in May 1956, for the Air Force to halt production pending resolution of its concerns. The most serious problem was a treacherous pitch-up tendency, encountered both in high and low airspeed ranges at certain G levels with angles of attack, frequently followed by engine compressor stalls that led to loss of power or total flameout. If the pitch-up, an uncontrollable flat spin condition oscillating between 20 and 70 degrees nose-up, occurred below 15,000 feet, Voodoo pilots were under standing orders to eject. The pitch-up problem was substantially remedied by installing a pitch inhibitor, would not allow the stick to be pulled past specific points at specific speeds, and the intakes and engine ducting were redesigned to diminish the possibility of compressor stalling. After what amounted to approximately 2,000 engineering changes, the hold order on F-101A production was finally lifted in November 1956, and the type was accepted for operational service in early May of 1957. Development and testing of the photo reconnaissance version, the RF-101A, followed the fighter version by about 18 months, but due to the setbacks in the fighter program, the photo recon versions entered the operational service at virtually the same time. The aircraft was fitted with an MA-7 fire control radar for both air-to-air and air-to-ground use, augmented by a low-altitude bombing system for delivering nuclear weapons, and was designed to carry a Mark 28 nuclear bomb. The original intended payload for the F-101A was the McDonnell Model 96 Store, a large fuel/weapons pod similar in concept to that of the Convair B-58 Hustler, but was cancelled in March 1956 before the F-101 entered service. Other operational nuclear payloads included the Mark 7, Mark 43, and Mark 57 weapons. While theoretically capable of carrying conventional bombs, rockets, or Falcon air-to-air missiles, the Voodoo never used such weapons operationally. The RF-101A made its first flight in June 1956, and differed from the fighter mainly in carrying 150 gallons of additional internal fuel and having a Lathan nose that housed 3 vertical and 2 oblique Fairchild cameras in place of the search radar and 20mm guns. The RFs shared the capability to deliver a single nuclear weapon carried on a centerline rack and were marginally faster than the Fs due to the reduced weight. F-101As became operational in May 1957, with the 27th Strategic Fighter Wing in their original bomber escort role, replacing their F-84F Thunderstreak. However, by this time, SAC had decided to abandon the long-range fighter concept. Even with its above-average range, the Voodoo could not escort the bombers, B-36s, and by that time B-47s and B-52s all the way to their intended targets. The F-101A's career might have ended then and there, but for the intervention of Tactical Air Command, which saw potential in the big fighter as a tactical nuclear weapons delivery system platform. Thus, in mid-1957, the 27th Strategic Fighter Wing became the TAC-controlled 27th Fighter Bomber Wing, and all F-101As were thereafter retrofitted with the low-altitude bombing system and other apparatus needed to complete their new function as nuclear strike fighters. By late November 1957, the last of the 77 F-101As had been delivered to the Air Force, 50 of them assigned to operational units, with the remaining 27 held for experimental and test purposes. F-101As served in a frontline role until 1966, after which they were phased out and turned over to the Air National Guard units. The first of 35 production RF-101As was delivered to the 363rd Tactical Reconnaissance Wing, TRW, at Shaw Air Force Base in May 1957. It was the first supersonic reconnaissance aircraft in the Air Force inventory, and, on November 27, 1957, as a part of Operation Sunrun, 4 RF-101As set a new transcontinental speed record. They flew round-trip between McGuire Air Force Base in New Jersey and March Air Force Base in California in 6 hours, 46 minutes, and 36 seconds, with an average speed of 721 miles an hour. In the mid to late 1960s, RF-101As were used as reconnaissance trainers and were all phased out of the active Air Force inventory by 1971. A few serviceable examples following the conversion to RF-101G standards were transferred to Air National Guard units. Pilots who flew the Voodoo were impressed by its performance, dubbing it the one-a-wonder, but they also considered it very unforgiving. Colonel C. Robert Oz Osborne Jr. said, "The F-101 was a lady, a fantastic airplane, but touchy, very touchy. It had to be flown properly." Air Force test pilot Richard Baird echoed that sentiment. "It's the biggest by-the-book fighter I've ever flown. The Voodoo would bite you. You really had to fly it strictly by the book." And reconnaissance pilot Colonel Jonathan Gardner noted that, "The first ride, you didn't fly it, you hung on to it." The improved F-101C and RF-101C were both ordered in March 1956. The Cs were externally identical to the A models, but had strengthened airframes to accept a higher load limit, and, in the case of the fighter version, were equipped from the start as tactical fighter bombers. All of the 47 F-101Cs built were delivered to the Air Force in 1957 to 1958, serving with the 81st Tactical Fighter Wing as nuclear strike aircraft until they were phased out in 1965 to 1966. The F-101C was the fastest tactical fighter in operational service until the advent of the Lockheed F-104, and on December 12, 1957, a stripped-down example set a new world record of 1,204 miles an hour, or Mach 1.83. The RF-101C, built in greater numbers than its fighter counterpart, entered operational service in September 1957, and the last of 166 was delivered in March 1959. RF-101Cs saw wide service with the US-based 363rd Tactical Reconnaissance Wing, the Europe-based 66th TRW, and the Far East-based 67th TRW. During the Cuban Missile Crisis in October 1962, RF-101As and Cs of the 363rd TRW flew low-level reconnaissance missions over Cuba. The RF-101C was the only Voodoo variant to see combat in Vietnam. In fact, as early as 1961, RF-101Cs of the 67th TRW, operating out of Kadena Air Force Base in Okinawa, began making surveillance flights over Laos and South Vietnam. During the same time period, 45th TRS Voodoos moved to Tan Son Nhut Air Force Base in Vietnam to cover operations in the south, and served as pathfinders for the first bombing mission against the North on February 8, 1965. Between 1965 and 1970, 33 RF-101Cs were lost to enemy anti-aircraft and missiles, and one to a North Vietnamese MiG-21. Starting in late 1967, as more RF-4Cs arrived to the takeover reconnaissance duties, Voodoos were restricted from operations over North Vietnam. They were all ultimately withdrawn from the combat zone by late 1970. Upon their return to the States, RF-101Cs were retired from active U.S. Air Force service, and many were turned over to the Air National Guard's units. In 1965, 29 F-101As and 31 F-101Cs were modified under the new designations RF-101G and RF-101H, respectively, to serve as unarmed reconnaissance aircraft with the Air National Guard units. The modification entailed removal of radar and armament and the installation of a nose cone housing cameras and new electronic components. RF-101Gs and Hs were operated by 3 Air National Guard units, the 154th TRS in Arkansas, the 165th TRS in Kentucky, and the 192nd TRS in Nevada. In early 1968, the seizure of the U.S. naval surveillance vessel Pueblo by the North Koreans led to President Lyndon B. Johnson to activate all 3 Air National Guard Voodoo units. Each served a rotational tour at Itazuki Air Force Base, Japan, and compiled impressive records, flying 19,715 tactical hours and 11,561 sorties, and exposing 841,601 feet of aerial film. The last single-seat reconnaissance Voodoos were removed from the National Guard service in 1976. The most numerically important and longest-lived Voodoo was the 2-seat all-weather fighter interceptor version, the F-101B. By the end of 1953, the Air Force's ambitious 2-step interceptor program with Convair, the Mach 1 F-102A, scheduled to be followed by the Mach 2 F-102B, redesignated the F-106A in 1956, was seriously behind schedule. An aircraft was needed to plug the gap between this so-called ultimate interceptor and the subsonic Northrop F-89 Scorpions, Lockheed F-94 Starfires, and North American F-86D Sabres serving with Air Defense Command. ADC's expression mission was strategic defense to interrupt and destroy Soviet bombers en route to the United States before they reached our shores. Late in 1953, the Air Force asked aircraft manufacturers to submit proposals for a new missile-armed all-weather interceptor under the classification Weapon Systems WS-217A. McDonnell offered a single or 2-seat adaptation of the F-101 that would incorporate new fire control and missile systems and use more powerful Wright J67 engines, license-built copies of the British Bristol Olympus that were supposed to produce 22,000 pounds of static thrust each. The Air Force selected McDonnell's proposal in mid-1954, specifying the 2-seat version, and issued a letter of intent in March 1955 for an additional batch of 28 aircraft and potential production of 68 more. The expectation was that the first flight would take place in mid-1956, and the prototype would enter the operational service in early 1958. After the letter of intent was issued, McDonnell requested the designation F-109 for the airframe portion of the WS-217A project, but the Air Force, evidently conscious of the funding obstacles associated with the new aircraft as opposed to the improvements to the existing type, called it the F-101B. Although McDonnell had the F-101B mock-up ready for inspection by September 1955, the entire Voodoo program was put on indefinite hold while the aforementioned aerodynamic problems with the F-101A were being ironed out. Further delays and uncertainties with the J67 engines led to a decision to use Pratt & Whitney J57P55 power plants, which featured longer afterburners and a thrust rating of 16,900 pounds per engine. The F-101B shared the center and aft fuselage sections and tail group of the F-101A series, and, other than bulged wheel well doors to house larger tires, the same wing platform. But the F-101B introduced a completely new, 4-foot longer forward fuselage section with a tandem cockpit layout for the pilot and radar operator. Also new was a Hughes MG tracking and fire control system, essentially an upgrade of the E6 system already utilized in the F-89D, and a rotary weapons bay that held 4 Hughes Falcon semi-active radar and infrared missiles. The first F-101B took off from Lambert Field in St. Louis on March 27, 1957, a year behind schedule, and the Air Force spent nearly 2 more years conducting extensive tests and evaluations before releasing the Voodoo interceptors to operational service. Flight performance met expectations, a top speed of Mach 1.66, a combat ceiling of 51,000 feet, and a normal range of 1,387 miles. But the F-101B had other problems that seriously hampered its operational effectiveness. The radar operator's position was poorly designed, and little could be done to improve it other than minor adjustments. Even more worrisome, the MG-13 fire control system did not adequately control the weapons on a platform as fast as the F-101. A proposal to replace the system with the more advanced MA-1 developed for the F-106 was rejected because of the cost involved. Deficiencies notwithstanding, the F-101Bs became operational with the 60th Fighter Intersector Squadron at Otis Air Force Base in Massachusetts on January 5, 1959. On the plus side, the 2-seater Voodoos had been extensively tested by the time they had reached ADC, and they finally gave the Air Force an interceptor capable of advanced performance at affordable cost, $1.7 million per plane, compared to $4.7 million for an F-106A. By the end of 1960, no fewer than 17 ADC squadrons were equipped with F-101Bs. Production ended in March 1961, with a total of 480 aircraft delivered. Beginning in 1959, McDonnell undertook a modification in which approximately 1 out of every 4 F-101Bs would be fitted with dual controls while retaining full ADC mission capability. Used for conversion and operational training under the initial designation TF-101B, these aircraft were redesignated F-101Fs in 1961, after 79 examples had been modified. Late production F-101Bs boasted upgraded fire control systems and the ability to carry 2 nuclear-tipped, unglided Genie MB-1s or AIR-2 missiles in place of the 2 Falcons. In a modernization program, Project Bold Journey, completed between 1963 and 1966, most F-101Bs were fitted with infrared sensors to facilitate tracking of hostile aircraft regardless of radar jamming, and also received a much improved pitch control mechanism that functioned through an automatic flight control system. F-101Bs/Fs began to be phased out of Air Force service in 1969, without having fired a shot in anger, and the last active duty squadrons operating the type, the 60th and 62nd FIS, retired their Voodoos in April 1971. Simultaneously, F-101Bs and Fs were delivered to the Air National Guard units, starting with the 116th FIS, Washington ANG in November 1969, and ultimately went on to fully equip 8 fighter interceptor units in 7 different states. The Air Force retained a small number of F-101Bs after 1971 for fighter interceptor training, and the last of those was retired in September 1982.
Introducing the most powerful fighter airplane in the world today, the F-101A Voodoo. Its mission, the support of strategic bombardment aircraft by escort and high-speed delivery of special stores on long-range intruder operations. Birthplace of the new Voodoo is the McDonnell Aircraft Corporation in St. Louis. This integrated defense installation includes over 2.5 million square feet of floor area. On the initial flight of the Voodoo at Edwards, the airplane went supersonic and the pilot reported excellent handling characteristics. Air Force evaluation flights were made at Edwards during late October and early November 1954. In long-range missions, the Voodoo has a combat radius of 1,000 nautical miles. It has a maximum level flight speed in excess of 850 knots at 35,000 feet. There is no limiting Mach number. The F-101A is the aerodynamic evolution of earlier Voodoo model, the XF-88A seen on the left, which made its first flight in October 1948. One of the major factors in the success of the present Voodoo design has been the retention of the aerodynamic parameters of the earlier model. During the engineering evolution of the F-101, engineers drew heavily upon their previous experience with the XF-88. Exhaustive wind tunnel studies indicated certain configuration changes. Wings were made thinner. The size and location of the tail were altered considerably. Engines were moved farther forward in the fuselage. Structural integrity of the new Voodoo is being carefully checked and proven by thorough physical tests. This test program is for the purpose of verifying the structural loads analysis and is proceeding on schedule. After the basic Voodoo design became reality, the production line took shape. The first 31 aircraft are being assigned to an accelerated flight test development program. This schedule ensures that subsequent production aircraft will be thoroughly proven prior to delivery to operational squadrons. Although over 1,000 jet fighters have been built by McDonnell, the F-101A Voodoo is the first major production contract with the U.S. Air Force. First flight, September 29, 1954. McDonnell Chief Test Pilot Bob Little is shown here, starting the job of proving the design concept, evolved in years of joint effort by the Air Force and McDonnell. The two Pratt & Whitney J-57 engines develop 10,000 pounds of thrust each. With afterburners, these engines make 28,000 pounds of thrust available to the pilot. Climb performance is spectacular, even for the most critical observers. Tests have shown that a takeoff could be completed in a fully loaded condition, even if one engine were lost at liftoff speed with the other engine in afterburning. The extremely thin wings and tail surfaces of the Voodoo enabled the big fighter to achieve transonic and supersonic speeds with no trim change. Wings and stabilator are swept back at an angle of 35 degrees along the quarter chord line. The Voodoo spans 39.7 feet and is 67.4 feet in length. Its overall height is 18 feet. The first landing of the F-101A at Edwards Air Force Base was closely observed by an F-86 chase plane in addition to the camera plane. Landing gear is of conventional tricycle type. Speed brakes are located in the aft fuselage section. The flight controls are push-pull rod operated with power cylinders located near the control surfaces. An artificial field system is utilized to provide proper resistance at the cockpit controls. The horizontal stabilizer is an all-movable slap type. The F-101 has excellent low-speed handling characteristics with normal touchdown at about 140 knots. The landing roll is reduced by use of the parabrake, which is opened by the pilot during the landing rollout. The big Voodoo handles easily on the ground, and pilots have been well pleased with the excellent vision from the cockpit during taxi operations. In fact, pilot visibility has proven exceptional under all conditions of flight. In the first 9 months of flying, a total of 404 flights have been made for a total of 381 hours, including 56 flights by Air Force test pilots. Only 29 days after the first flight by the contractor, the Voodoo was turned over to the Air Force for preliminary evaluation. Here, Brigadier General J.S. Faulkner of Edwards Air Force Base prepares to take the F-101 upstairs. As General Faulkner climbs into the cockpit, Bob Little follows for a last-minute briefing on the controls. Air Force pilots participating in the evaluation program, in addition to General Faulkner, include such old pros as Colonel Pete Everest, Major Gus Julian, Colonel Royal Baker, Major Jim Butler, Captain Dick Hara, Colonel Ken Schultz, Major Stu Childs, Major Ray Hunt, Major Bob Stevens, Captain Burge Gibbons, and Colonel H.A. Haynes. An interesting feature of the Voodoo is the provision for dual droppable main wheels, which will enable the airplane to operate from steel mat fighter strips. As General Faulkner eases the throttles forward, the 28,000 pounds of thrust accelerates the 38,000-pound Voodoo rapidly. The 30,000-pound thrust engine of the squadron aircraft will give even better performance. This evaluation comprised a qualitative appraisal of climb performance, subsonic and supersonic stability, maneuvering flight, stalls, and general handling characteristics during formation flight. In the design of the Voodoo, McDonnell kept 3 primary concepts in constant focus. First, performance. Second, good handling and stability characteristics, and third, easy maintenance. A closer aerial look at the Voodoo shows the large fuselage in which over 2,000 gallons of fuel are carried. Total fuel capacity is 3,254 gallons, of which 900 gallons are carried externally. Firepower of the Voodoo includes 4 M39 20mm guns, which fire a total of 1,500 rounds or 375 rounds per gun. The guns are installed forward of the cockpit in the lower fuselage, making them readily accessible to armament crews. An MA-7 fire control system is installed. Another of the tactical functions of the Voodoo is that of carrying special stores on long-range intruder missions. This Voodoo taxis out with the Model 96 store installed. The store is a McDonnell-designed supersonic shape, housing a 2,700-pound warhead plus 849 gallons of transferable fuel. This weapon is designed to be used and released throughout the speed range of the airplane. The Voodoo accelerates down the runway as handling characteristics are checked in high-speed taxi runs before actual flight. The 96 shape, which is almost 32 feet long and weighs slightly under 10,000 pounds, gives the Voodoo a striking power never before found in fighters. When carrying smaller special stores, 2 450-gallon tanks can still be carried to extend the combat radius. With all 3 store stations thus used, the gross weight will be about 50,000 pounds at takeoff. Shown here is a takeoff with 2 full 450-gallon tanks installed. This is the external fuel arrangement used in the standard fighter configuration for missions demanding maximum radius of action capability. The takeoff performance speaks for itself. After progressive flight tests, first with empty external tanks, then with 2 full tanks, the Voodoo is set for the big test. 3 fully loaded external tanks and a full internal fuel load. The centerline tank is used to simulate a Mark 7 store, which is both smaller and weighs less than the loaded tank shown here. Although the gross weight of the airplane is increased greatly in the full fuel load configuration, the powerful Voodoo climbs out sharply. At maximum weight, the takeoff ground roll is only about 4,000 feet on a standard day. The Voodoo's rapid climb from takeoff poses a serious chase plane problem. Here at Lambert St. Louis Field, General Boyd, commander of WADC, lands after an evaluation flight. Improvements have been incorporated into the Voodoo since General Boyd previously flew the airplane at Edwards. Among the accomplishments of the flight program were level flight speeds of Mach 1.5, maximum altitudes of 54,300 feet, and evidence of unsurpassed maneuverability at supersonic speed. The General taxis the Voodoo onto the McDonnell ramp and drops his parabrake. General Boyd, seen here climbing out of the sleek fighter, is greeted by J.S. McDonnell, president of McDonnell Aircraft Corporation. Development of high-performance military weapons demands the closest interest and cooperation of those possessing tactical knowledge and of those possessing industrial know-how. With the test and development program now well underway at Lambert Field, impressive takeoff scenes of the Voodoo such as this have become commonplace. While within the walls of the plant, the experienced McDonnell team is busily building toward full-scale production of the powerful and versatile Voodoo to add further to the striking power of the United States Air Force.
Well, here she is, the Voodoo. Your briefing told you a lot about her and what makes her go. Now it's about time for that first ride. First, you'd better check over Form 781. If everything is in order, let's look the airplane over before you climb aboard for your first hop. Be sure the pitot cover is off and the plastic nose is secure. See that camera windows are clean and undamaged. Check the landing lights and steering unit. Inspect the nose gear doors, up latch, and collar assembly. See that brake system emergency air bottle has 3,000 pounds pressure, and the down lock pin is removed. Make sure the split vertical camera doors are closed and secure. Check the inlet duct and the security of all doors which could be drawn into the intake. Examine the wing for dents or disfiguration, and that the stall fence is secure. Check the wingtip and position lights. The aileron hinge area, the flaps, and the flap well area must be clear. Inspect the gear fairing doors and check condition of gear uplock. Down lock should be secured. The inboard gear doors should be down, and the engine fairing doors secure. Check tailpipe areas for fuel accumulation. Make sure there are no loose rivets and that keel plates are secure. Visually examine the fuel system ram air inlet, the vertical stabilator, the horizontal stabilator, drag chute compartment, position lights, and the rudder. Complete the walk-around inspection by checking the same items on the other side on the airplane. With the walk-around check completed, it's time to climb aboard. The canopy and seat safety pins must be in place, and the canopy and seat initiator hoses should be secure. Once you've settled in the cockpit and have strapped yourself in, the mechanic will pull the canopy safety pin. On cross-country flights, take this pin with you. Before beginning the cockpit check, make sure the battery switch is off and that the landing gear handle is down. Now check the shoulder harness and that the safety belt locking key is inserted. Be sure the lanyard is clear of the harness and equipment leads. Connect the oxygen mask. Be sure to double loop the connector tie-down strap around the parachute chest strap. Connect the G-suit and microphone lead. Turn the battery switch on momentarily to adjust the seat. Use the hand crank to adjust the rudder pedals. Then check the drift computer control knob and the photo compartment temperature controls, which are on the pedestal panel. Make sure the stick grip is firmly attached. Now let's run through the cockpit check with external power off. Begin at the aft end of the left console and continue clockwise around the cockpit. We'll take the check items in groups. This is our first group. Set the anti-G-suit pressure regulating knob. Emergency camera door switch, normal. The APS 54 power switch, off. Check the split vertical, the tri-camera, and forward camera station control panels. Then the camera master control panel. The next check items lie in this general area. Fuel transfer selector switch, fuselage, fuel quantity selector knob, total. Pitch up warning horn switch, on. Pitch up warning pusher switch, on. The next group will complete the left console check. Wing flap lever, retract. Landing light switch, off. Check the circuit breakers. Tank jettison switch, normal. Throttles, closed. Speed brake switch, neutral. Drag chute handle, in and secure. Rudder trim switch, neutral. Engine master switches, off. Engine start switches, off. Fuel control switches, normal. Antenna selector switch, upper. Now check the left vertical console. Emergency air brake handle and emergency gear extension handle, in and secure. Landing gear handle, down. Emergency speed brake switch, normal. The next area is the main instrument panel. Check the viewfinder control panel. Turn switch, normal. Radar warning switch, full. Set the airspeed and Mach indicator. Next, set the altimeter. Then the clock. Check the viewfinder, the accelerometer, and the vertical velocity indicator. Then set the pressure ratio gauges. These items are all on the right vertical console. The boom and probe IFR switches in and retract. Battery switch, off. The left and right generator switches should be on. On the forward right-hand console, check the following. Oxygen quantity gauge, oxygen regulator lever, normal. Oxygen supply lever, on. Cabin pressure switch, normal. Pitot heat switch, off. Windshield anti-icing switch, on or low. Windshield blower switch, off. Set the cabin air temperature control knob and the defroster knob as desired. Farther back on the right console, check the following. VHF navigation radio power switch, off. Standby compass light switch, off. Face heat knob, off. Set the ground position indicator controls. Check the J4 direction indicator controls. IFF master control knob, off. Check the autopilot. These items complete the power off check. Set all interior and exterior light controls. Check that all camera circuit breakers are in. Then check the supply of spare lamps. With external power connected, check fuel quantity. Turn the selector knob to obtain individual tank readings. After completing the fuel quantity check, return the selector knob to the number 2 cell, because this is the cell you will monitor during takeoff. Check the 3 landing gear indicator lights. They should be on. The flap position indicator should show flaps up. Check the operation of the UHF command radio, voice and DF, and VHF navigation radio. IFF should be in standby until airborne. Check the cockpit lights and the exterior lights. Just before starting the engines, check the operation of the fire warning system in both flashing and steady. Then the warning light's dimming circuit by depressing the test switch after turning the instrument light knob on. Now make sure the throttles are closed. Then, to start the left engine, turn the left engine master switch on and actuate the left engine start switch. When the RPM gets up to 12 to 16%, advance the throttle to idle. The ignition is automatic. If you've got a start, you'll get a rise in exhaust temperature. Fuel flow should indicate 850 to 1,100 pounds per start. If flow is less, you may get a false start. If more, you'll probably get a hot start. Normal engine idle RPM is between 55 and 65%. The exhaust temperature should not exceed maximum temperature during transition to idle RPM. The oil pressure should be at least 30 psi. With one engine started, move the stick rapidly to check the hydraulic gauges for momentary pressure drops. Visually check control surface movement. After starting the other engine, have the mechanic disconnect external power. With both hydraulic systems providing normal pressure, the warning light should be out. Turn the battery switch on. Turn the yaw damper switch on. Now let's check the pitch-up warning system. While holding down the test button, have the ground crew rotate the probe sufficiently to engage the pusher as the stick is moved aft. Check for pusher release after short forward stick travel. Also, check emergency pusher release by pressing the autopilot disengage trigger on the stick handle. Open and close the speed brakes. Extend the flaps. Pull the seat safety pin now, and you're about set to taxi out. With taxi area clear, signal the ground crew to remove the chock. Hold the airplane with brakes until you're ready to roll. Advance throttle slightly to get rolling. Taxi speed is adequate with idle power. To save wear and tear on the brakes, use nose gear steering for all taxi. Take it easy going around corners, and don't ride the brakes. Use the brakes carefully when coming to a full stop to avoid landing gear chatter. The canopy warning light will go out when the canopy is down and locked. Taxi into takeoff position. Let the airplane roll straight ahead to align the nose gear. When you're squared away, check the safety belt and shoulder harness. Make sure the equipment leads are untangled. Unlock the shoulder harness inertia reel. Cycle the controls. Check the takeoff trim light and the flap position indicator. If pre-takeoff engine checks are desired, make run-ups in both normal and emergency fuel control settings. Run engines up individually to avoid slipping tires on their rims. Run up to military power and check the pressure ratio indicators for proper preset value. After run-up checks are completed for both engines, we're all set. Okay, let's roll. Move both throttles to about 88%. Release brakes and advance the throttles to military. Recheck the pressure ratio gauges. Use nose gear steering until the rudder becomes effective at about 70 knots. Ease the stick back at 150 knots to get the nose gear off. Then relax stick back pressure to hold attitude. The airplane will fly itself off at about 165 knots. Raise the gear and flaps quickly to prevent exceeding gear and flap placard speeds. Afterburner takeoffs are not recommended on your first couple of flights because the airplane accelerates so rapidly. However, while you're climbing, let's imagine an afterburner takeoff. Advance the throttles to military, then shift them outboard to light the burner. Although she'll get up to speed in a hurry in afterburning, ease the nose gear off at 150 knots and relax stick back pressure just as you did in military. Take it easy, though. Don't over-rotate and get into a non-flying attitude. Get the gear and flaps up as early as possible. Remember, you're handling more thrust per pound of airplane than you've ever felt before, so it is imperative that you stay ahead of the airplane. While we're talking about afterburner takeoffs, we might point out that the time from brake release to best climb speed is very short. In fact, it only takes about 60 seconds. And when you reach the best climb speed, you'll have to climb at a steep angle to stay at that speed. Use the Mach meter to maintain best climb speed and control attitude with the artificial horizon. In military power, of course, attitude isn't as steep and rate of climb not as high. Squadron doctrine. It's up to you, however, to make the most out of the time. You are the one who must get the feel of the airplane and develop correct flying technique. Although she's big, you'll find the Voodoo handles light and easy. In short, she feels like a fighter. After you've flown her around a while, you'll learn to enjoy the comfort of twin-engine reliability. Along with its supersonic performance, the Voodoo has fine handling characteristics. Like any airplane, though, it has its limitations. That's why it's important that you know the placards and fly accordingly. Make it a habit to study the Dash 1 handbook. Hashing over the airplane's flight characteristics with other Voodoo pilots will help also. The Voodoo wasn't designed for optimum maneuvering capabilities at subsonic speeds. It's a true supersonic airplane, and maneuvering capabilities at supersonic speeds are excellent. Maneuverability is, of course, restricted by structural strength, so it's up to you to know your handbook placards. Let's slow down now and check the slow speed flight characteristics with gear and flap up. As you know, the Voodoo, as well as other Century fighters, has a characteristic called pitch-up. The nature of this phenomenon was explained thoroughly during your briefing, so we need not go into it here. What we want to emphasize is that pitch-up is easily avoided. All squadron aircraft will be equipped with a pitch-up warning system, just as the airplane you're flying. The warning system sounds a horn as you approach the pitch-up boundary, and actually pushes the stick forward should you reach the pitch-up boundary. While you're flying around at low speeds, drop the gear and flaps to see how she handles in landing configuration. You'll recall from briefing that with either gear or flap down, the pusher part of the pitch-up warning system is not operative. However, the horn warning part of the system does stay operative during landings and takeoff. Subsonically, the aircraft gives good buffet warning, and the horn is a second indication that you should ease the stick forward. Before you head for home, fire up the burners and check level flight acceleration. You'll find acceleration impressive at all altitudes, and you'll enjoy the high-level flight speeds the Voodoo can reach. On an average day, for example, in afterburning, you can accelerate from 0.95 to 1.5 Mach in 3 to 4 minutes. Flying qualities are stable, and control characteristics positive throughout the placard speed envelope of the airplane. As you approach home base, make these checks before entering the pattern. The camera master control switch should be off. Check fuel quantity and monitor number 2 cell. Hydraulic gauges should read normal. Check safety belt and unlock inertia reel. In the pattern, adjust the throttles to maintain speed and altitude. At about 350 knots, make your brake. Moving into the downwind leg, adjust power to about 80% and open the speed brakes. Close the speed brakes when you get below 250 knots. Then drop the landing gear. Lower the flaps at any speed below 250 knots. On the base leg, the speed should be down to about 190 knots. For a landing with 3,000 pounds of fuel remaining, you should set up a smooth pattern from this point so you'll flare out at 170 knots. From about 2 miles out, make a straight-in final. Use a mild approach angle, holding the airspeed at 170 knots. Be sure to cross the end of the runway before you chop power. Fly the Voodoo onto the runway and touch down at about 150 knots. Pull the drag chute and ease the nose down gently at about 110 knots. When the nose gear is firmly on the runway, nose gear steering can be used. Release the drag chute in a clear area and pull up into the line. Hold the aircraft with brakes until wheel chocks are in place. To shut down the engines, close the throttles and turn off the engine master switches. Now install the seat safety pin. Make sure all electrical switches except generator switches are off before you leave the cockpit. Well, that's it. Your first ride in the RF-101 Voodoo. A few more familiarization hops and you'll feel entirely at home in this airplane. Yes, the briefing was detailed and intensive, and it took a lot of work on your part. But you'll find it worthwhile, because you know now the Voodoo is a lot of airplane.
Operation Sunrun was a demanding shakedown for McDonnell RF-101 Voodoos, their pilots, airmen, and behind-the-scene personnel. It was a record-breaking mission, exacting the utmost in painstaking planning and cooperation. While Sunrun was all of this and more, the mission was nevertheless in line with the preparedness philosophy of today's Air Force, realistic and tough. What was Operation Sunrun? Test the readiness of the McDonnell RF-101 Voodoo to fly nonstop from Los Angeles to New York and back to Los Angeles, a distance of 4,900 miles at top speed, with all photo equipment operating. At the same time, bust a few speed records. 6 airplanes in all, 4 to New York, 2 to make the round trip back to Los Angeles, and 2 to act as spares. Responsibility for Operation Sunrun was assigned to the 363rd Tactical Reconnaissance Wing of the Tactical Air Command from Shaw Air Force Base. In November 1957, pilots were well along in practice with ARDC and SAC tankers over Southern California. Officers selected to fly Operation Sunrun were carefully chosen with emphasis on experience and ability. Lieutenant Colonel W.H. Nelson was the commanding officer. Here are the Sunrun pilots. Captain Ray W. Schreckengoss, Jr. of Sebring, Ohio. Major Stanley R. Sebring of Beverly Hills, California. Captain Robert M. Sweet of Baronet, Wisconsin. Captain Donald D. Hawkins of Alhambra, California. Captain Robert E. Burkhart of Alliance, Ohio. Captain Robert J. Kilpatrick of Bristol, Connecticut. Lieutenant Gus B. Platt of Midland, Texas. On November 27, 1957, the stage was set for Operation Sunrun. The planes were ready, and the pilots poised for the real thing. After an early morning briefing, pilots and airmen made last-minute inspections of their aircraft. Sunrun was on. Time to taxi out. Remove safety pins and disconnect external starting leads. Then, pull the wheel chuck. The airmen's jobs were through for the time being, except to sweat out each second until the mission was completed. During the briefing session, pilots had drawn lots for their assignment. Accordingly, Captain Schreckengoss, Sweet, Kilpatrick, and Lieutenant Platt were to go to New York, with Captain Schreckengoss and Sweet returning to Los Angeles. Captains Kilpatrick and Platt were to land at New York, and Captains Hawkins and Burkhart were to man the spare aircraft. The afterburners were kicked in and Operation Sunrun was underway. For Kilpatrick and Clapp, it meant about 2,450 miles of flying, while Schreckengost and Sweet had to cover 4,900 miles. The number 2 Voodoo becomes airborne, and the others follow at predetermined intervals. The first refueling rendezvous point with KC-135 tankers was near Albuquerque, New Mexico. This was the pattern. Fly at top speed, meet the tankers at designated spots, gas up, and blast off again. Meanwhile, navigate, get instructions from GCI, make radio transmissions, check instruments, and fly the airplane. The second Voodoo slides into position beneath the tanker. And so Operation Sunrun progressed as rehearsed, the Voodoos taking on fuel according to schedule. In a short time, word got back to headquarters that the Voodoos had made their first refueling rendezvous successfully, and 4 were off to New York. The 2 spares were on their way back to the starting point. About 3 hours later, Brigadier General Stephen B. Mack, commander of the 363rd Reconnaissance Wing, announced that all 4 Voodoos had broken the west to east record, arriving at New York within minutes of each other. Lieutenant Platt, averaging 781 miles an hour, made the best time, arriving in New York in 3 hours and 5 minutes to chop about 17 minutes off the old record. Captain Ray Schreckengost was first to get back to Ontario, California, making the round trip in 7 hours and 7 minutes. On the Los Angeles to New York to Los Angeles dash, Captain Schreckengost had averaged over 671 miles an hour. General Mack was first to congratulate Captain Schreckengost. Newsmen and well-wishers quickly swarmed about the airplane. Reporters, TV, and radio announcers crowd Captain Schreckengost as he explains that Captain Sweet is coming in right on his heels, making still better time. This information spread quickly, and newsmen prepared to welcome the latest breaker of the round-trip record, a record which lived only a few minutes for Captain Schreckengost. They had little time to waste. Captain Sweet soon roared across the finish line. He had covered the 4,900 miles in 6 hours and 46 minutes, averaging over 721 miles per hour. It was the first non-stop round-trip Los Angeles to New York to Los Angeles flight made at supersonic speed. Captain Sweet makes a smooth landing, completing his record-breaking flight. Here is Captain Bob Sweet, new holder of the round-trip record. General Mack later awarded the Distinguished Flying Cross to Captain Sweet and Lieutenant Platt, and the Air Medal to Captains Breckengoff and Kilpatrick. In all, 7 official world, class, and national records were established by RF-101 during Operation Sunrun. 3 of these marks were shattered in a matter of minutes, each by a Voodoo hot on the tail of another as they crossed the finish line in New York. This remarkable achievement, where 4 out of 4 aircraft completed their difficult assignments, is a tribute to the skill and organization of the Air Force and to the reliability and performance of the Voodoo. Operation Sunrun was a real success. Hot on the heels of Operation Sunrun and equally successful was Operation Firewall. The mission? Break both the national and world speed records. The McDonnell F-101A Voodoo, the most powerful and longest-range fighter bomber in operational service, was given the assignment. Powered by 2 Pratt Whitney J-57 engines, the Voodoo can operate under all weather conditions, and its unique in-flight refueling capabilities enable it to carry atomic weapons at extreme ranges. The speed run was staged at Edwards Air Force Base in California on December 12, 1957, over a measured distance of 10.1 miles, in accordance with international rules. National Aeronautic Association officials placed field, speed, and altitude measuring instruments in the Voodoo and observer planes before the flight. Timing devices were installed on each end of the speed course. These are special cameras which photograph a contesting airplane as it passes directly overhead. Major Adrian E. Drew, commander of the 481st Fighter Bomber Squadron, 27th Fighter Bomber Wing of the Tactical Air Command, was selected to pilot the Voodoo in the attempt to crack the world and national speed record. At this time, the world record was 1,132 miles an hour, set by L.P. Twist of England in an experimental Fairey Delta fighter. The United States record of 1,015 miles an hour was set in 1956 by Commander R.W. Windsor of the Navy in an F-8U-1 Crusader. Major Drew was well qualified to make the speed dash. As a former Strategic Air Command F-101 project officer, he had logged many hours in test flying the Voodoo and was therefore entirely familiar with its capabilities. Shortly after 8:30 a.m. on December 12, 1957, Major Drew was climbing his Voodoo to the speed run altitude of 39,000 feet. In accordance with the rules, National Aeronautic Association officials were riding as observers in T-33s to witness the flight. To correct for wind effects, the rules required a run in each direction over the measured course. Here, as the Voodoo approaches the course, distances from the first marker are relayed by radio.
20 miles, 25. Coming up on 10 miles from West Outer Station. 10 miles, West Outer Station.
262729, turn your cameras on.
Camera on 27. 5 miles, West Outer Station. 5 miles. 4 miles, West Outer Station. 3 miles, West Outer Station. 2 miles. 1 mile, West Outer Station. Stand by. Mark.
Mark over West Station.
6 miles. 25. 5 miles 25. 4 miles. 2 miles. 1 mile 25. Stand by. Mark.
Then Operation Firewall was over. Had he broken the record? Major Drew believed he had, but also realized that his speeds of 1,212 miles an hour on the initial pass and 1,203 miles per hour on the return pass would have to be verified by technical data before becoming official. Later, on orders from Major General Chester E. McCarty, 12th Air Force Commanding Officer, Major Drew had flown his Voodoo to Los Angeles to meet the press. He knew then his record was official. General McCarty, acting for the Tactical Air Command, decorated Major Drew with the Distinguished Flying Cross in the presence of members of the press, TV, radio, and newsreel men. General McCarty announced that the Voodoo had averaged 1,207 6/10 miles an hour, breaking the world record. This was 75 miles an hour faster than the British mark and nearly 200 miles an hour faster than the former U.S. record. Like Sun Run, Operation Firewall was a record-smashing success.
Hello, I'm Colonel Mill Atkins of the Air Defense Command, United States Air Force. As I'm sure you know, the mission of the Air Defense Command is to protect this continent from any hostile air attack that might be launched against us. And as I'm sure you also know, the units of the Air Defense Command, which are located here in your community, are a very important part of this operation. In a very real sense, they represent your personal protection against any such enemy air invasion. My purpose in visiting with you today is to tell you a little more about how we in the Air Defense Command conduct our mission. Particularly, I would like to familiarize you with our newest weapon system, the McDonnell F-101B interceptor, which is now entering squadron duty here. In a few moments, I would like to discuss our mission with you. However, first, may I present to you the story of the outstanding McDonnell F-101B Voodoo.
This is the F-101B Voodoo Jet Long-Range Interceptor, the newest and most potent weapon system in the operational squadrons which will defend the North American continent. It is your most effective protection against enemy aircraft which approach the borders of the United States with hostile intent. No airplane in the history of air power has had better qualifications for a particular mission. For the Voodoo is more than just an airplane. It is a complete weapon system, the culmination of a 10-year engineering and manufacturing effort by the McDonnell Aircraft Corporation of St. Louis, Missouri, in conjunction with the Air Force. Let us examine briefly the basic ingredients of this lethal two-man weapon system. First of all, the Voodoo has sizzling speed, the ability to get off fast and intercept enemy formations before they can come within range of our territory. Second, the Voodoo has extreme range, which makes it most capable of carrying out missions of both offense and defense. Third, the Voodoo has great firepower with the ability to deliver multiple combinations of bombs, missiles, and rockets, which are directed against enemy targets by the radar observer, who serves as the attack director. And fourth, the Voodoo has been designed with a high safety factor. During its first year of tactical operation, the Voodoo had the lowest accident rate of any operational fighter in the history of the United States Air Force. These four characteristics, speed, range, firepower, and safety, have emerged through years of careful experimentation and research. Thousands of engineering man-hours were expended to explore every facet of this complex fighter before production could get underway. In the McDonnell Physical Test Laboratory, engineers carried out an exhaustive program to prove the structural integrity of the new fighter. And as McDonnell engineers and technicians perfected the Voodoo airframe, the power plant, two Pratt & Whitney J57 turbojet engines, was undergoing parallel testing. Hundreds of hours of ground testing of these engines took place prior to first flight. The complex electronic weapons control system and radar installation was developed concurrently by the Hughes Aircraft Corporation. This vast coordinated effort was culminated in August 1954, when the first Voodoo was airlifted to Edwards Air Force Base in California for the flight test phase of the program. Just 1 month later, the Voodoo completed its first test flight, and the McDonnell flight test crew realized immediately that the Air Force has a winner. Air Force evaluation began just 37 days after the first flight. More than 3,000 development flight hours were amassed during the test program, and the Voodoo has emerged as probably the most completely developed complex airplane any operating squadron has ever received. The four basic concepts of speed, range, firepower, and safety have been proven again and again in a series of achievements that have been heralded throughout the world. One of the Voodoo's most notable achievements was Operation Firewall, the successful assault on the world speed record which had been held by the British. The record toppled before the Voodoo's onslaught on December 12, 1957, at Edwards Air Force Base, California. The Voodoo completed both legs of the measured 10-mile course at a blistering average speed of 1,207 miles an hour. The big fighter was piloted by Major Adrian E. Drew. Less than a month previous, on November 27th, a flight of 6 photo reconnaissance Voodoos underscored the long range, speed, and dependability of the Voodoo in Operation Sun Run. At stake were the transcontinental speed records of the United States. The Voodoo's range was extended by mobile filling stations in the sky, giant tankers which rendezvoused with the Sun Run airplanes. Voodoo performance was flawless, so good, in fact, that the two airplanes that had been designated as spares turned back after the first refueling. The 4 remaining Voodoos went on to make aerial history. Before the day had ended, all 3 transcontinental records, west to east, east to west, and round trip, had been swept up by the Sun Run Voodoos. Record time from west to east was 3 hours, 7 minutes. The round trip was made in 6 hours, 46 minutes. Mobile Zebra, another Air Force operation, again proved the operational mobility of the Voodoo. Leaving from Shaw Air Force Base, North Carolina, the group flew to the West Coast and then island hopped the entire Pacific to arrive in Tokyo. During the return trip, a new speed record from Japan to Hawaii of 6 hours, 3 minutes was set. And the records continue to pile up. A flight of Voodoos from Austin, Texas, completed a 5,950-mile hop to England in a record 10 hours, 45 minutes. Another non-stop endurance flight, this one of 11-hour duration for a distance of 5,600 miles, was made from Bergstrom Air Force Base, Texas. In June 1958, the Atlantic was again spanned from Washington, D.C. to Belgium in 6 hours, 12 minutes. While Voodoo-equipped operational squadrons continued to dissolve existing records, engineers and technicians sharpened the Voodoo's sting. The interceptor Voodoo is capable of delivering advanced nuclear weapons in all kinds of weather, at any target, airborne or ground, visible or invisible. And vitally important to any air defense system, the crew of this manned interceptor can distinguish between friend or foe before it's too late. Enemy bombers, single or in groups, can be vaporized by one Voodoo-borne Genie air-to-air nuclear rocket. The Voodoo can also pack a lethal load of Falcon missiles. So the end result of 10 years of continuous evolution is a modern weapon system with every basic ingredient for the defense of the free world. The speed to overtake and the range to intercept. The firepower to destroy all types of targets in any weather. And the margin of safety to return from the mission. It is these basic concepts, designed into every inch of the Voodoo, that the Air Force has polished to a high luster through the most exhaustive test program ever known. It is these concepts that will help ensure our freedom.
If you enjoyed this video, please remember to like and subscribe. And as always, thank you for watching.